Hello everyone, welcome to Software Testing Expert Talk series. Today we have a guest who has close to 15 years of experience in software development and testing in the IT industry so far. He is a test automation consultant and trainer and has worked with many big companies in his tenure so far. Currently, he is holding a role of Director of International Academy at one of the prestigious organizations across the world. In his career, he has covered everything from building and maintaining test automation solutions that works to creating and implementing test automation strategies across teams and organizations. He is an experienced corporate trainer and has successfully delivered many courses on test automation to companies in the Netherlands and abroad. His courses are built on the experience he has gained in 15 years of being a test automation consultant. So he knows what works in test automation and what does not. He is a person who enjoys public speaking and has taken part in many international conferences like Agile and Automation Days, UK Star, Dutch Testing Day, and has delivered talks at numerous other conferences in the Netherlands and abroad. Not only this much in his introduction, he is founder of ontestautomation.com. Plus, he is also an author of a couple of ebooks named as A Test Automation Learning Path, Service Virtualization, Implementation, Practices, and Trends for On-Demand Test Environments. Now I believe you must have got an idea about the guest for today's STET session. Yes, our guest is none other than Bas Dijkstra. Welcome to our show, boss.
Thank you so much, AJ. I don't think I've had an introduction that enthusiastic before. So thank you very much for that.
All right. Thank you, boss. Today, boss will talk about how we can do API testing using Python. Let's hear directly from him. Over to you, boss.
Thank you so much, AJ. Let me go ahead and share my screen. All right. So this is a little bit of an experiment for me as well, in that there are no slides. Typically, when I do talks, live demos, there are slides. Today, there will be no slides. It will be just me talking, having a discussion with AJ, and lots of live coding in between. As AJ already said, what we're going to do today, what I'm going to talk about today is API testing, writing tests for APIs in Python using the requests library and PyTest. Why API testing? Why not? API testing is becoming ever more popular, and people are finding out that writing tests at the API level can be done efficiently, results in good test coverage, and because APIs are ever more present in modern software applications and systems, having the skills to interact with applications at the API level is becoming ever more important. So traditionally, a lot of automation has been done at the UI level, the graphical user interface level. But nowadays, more and more of the automation work is shifting down in the application stack, more and more towards integration testing at the API level. So that's what we're going to explore today, really. The reason I've chosen Python as my language of choice is because there's not a whole lot of coding you need to do to write useful, meaningful, and powerful tests for your APIs. Python has a lot of excellent libraries that can help you write tests for APIs. And before I get started coding, I'm going to quickly introduce the two main libraries that I'll be using today. First of all, like with so many automation efforts, we need a testing framework, a unit testing framework. Python has a lot of different unit testing frameworks. but arguably the most popular and the most versatile one is PyTest. So PyTest is currently at version 6.2.5. It's a very mature framework. It's powerful, and it's one of the most expressive unit testing frameworks I know in the Python ecosystem. So that's why we're using PyTest here. And as you've probably understood from the title of this session today, we're going to be using requests as well. You can already see from the description here on the page that requests is a simple yet elegant HTTP library. Basically, if I had to put that in my own words, it means that it's powerful and it's expressive, and you can write meaningful tests using requests and PyTest in Python without having to write a whole lot of code. It is simple to use, but extremely powerful, as you'll hopefully see once we get started writing some actual tests for our APIs. If you go to the requests documentation page, you'll see a lot of more about all of the features that requests can, all of the features that requests offer. I'll never be able to cover all of them in this session. So we'll get started at the beginning. I'll be showing quite a few features of the requests library, but there's no way that I'm going to be able to cover them all in just about an hour, which is all the time that we have. If you want to know more about the request library, I highly recommend just check out the documentation. It's well written, it's easy to understand, and basically everything that the library can do is in there. Of course, because we are going to write some tests for an API, we also need an API to test against. So there are thousands, if not millions, of APIs available there. The one that I've chosen for the examples, for the coding exercises that I'll be doing today, is the JSON placeholder.topico.com API. That API has a number of different endpoints. It's a fake API for testing and prototyping. It has a number of different endpoints. You can retrieve data about posts, comments, albums, photos, to-dos. And we're going to start out with some user data. So, and mainly the main operation that we're going to be focusing on is this one, an HTTP GET. So I'm retrieving some data from this API that is related to a user with user ID 1. So as you can see in the response, there's a user ID, there's a name associated with that user ID, a username, an email, an address, a phone, a website, and a company, some company data. So plenty of data to work with. If we inspect our network tab, we can also see in the response that there are a number of different headers associated with the response. So there's no need for you to understand all of these, but I'm going to be referring to some of them when I'm doing the exercises. Headers, for those of you who are less familiar with these REST APIs, are they contain metadata, a description about the response, specific characteristics of the response. It's not the actual data, but it's other information that might be useful for the receiver of this response, so the party that sent the request. For example, one of the most important ones is the content type header, which, this one, which tells the receiver, the recipient of this response, what data type the actual response is in. And so in this case, it tells the receiver of the response the data that you see is in a JSON format, and the used character set is UTF-8. So that's our API. It's as simple as this. Most of the time, we are going to be retrieving some data and verifying some specific properties of this response. So what I've prepared here for this session are a number of simple coding challenges that I'm going to talk you through in this session, so you'll see what's going on. By the way, I'm using PyCharm. For those of you not familiar with the IDE, it's basically IntelliJ, but for Python. It's one of the many IDEs that you can use for Python. It's definitely not the only one. I'm not going to say that it's the best one. I just happen to like it very much, so that's why I'm using it here. By the way, just checking, AJ, is this readable, or should I increase the font size for you?
No, this is good. I can read it.
That's good. Then I'm going to assume that everybody's watching this webinar can also read it fine.
Right.
If not, by the way, if it's hard to read, all of the code that I'll be showing, so both the exercises and the answers to all of the exercises, I'm going to hide them. I don't want to give them all away. I don't want to spoil the surprises here. They can be found on GitHub as well. So if you go to this URL, this contains the exact code that I'll be working with in this session.
That's great.
Together with a bit of descriptions on how to actually install the dependencies and run the code for those of you not as familiar with Python as not yet that much familiar with Python.
Oh.
Awesome. So what I've prepared here is just a Python module, exercises.py, with a number of tests. And as of now, when I'm running these tests, they all fail because there's a lot of work we still need to do. What I've prepared is basically they are empty tests. The only thing that, or not empty because there is an assertion statement in there, but the only thing they do is just assert false. And what we're going to do here is make these tests pass. So I want these tests to pass. Let me quickly go into the settings and where's this again? Languages and frame 5.
Boss, before we
I forgot what this is. Yeah, sure. AJ, go ahead.
So before we take a deep dive into API testing using PyCharm, so I have a generic question to ask from you.
Sure.
So what suddenly happened, like why all the organizations are focusing more on API testing rather than, focusing more on our traditional functional testing?
So you want to know why?
Yeah.
Well, it's so what we've seen traditionally in test automation is that people started to write tests that replicate what an end user does, how an end user interacts with an application. And those are important tests because we need to know that an end user can perform specific actions with in an application through the graphical user interface. However, for a lot of tests, it's definitely not the most efficient way to get the information that you're looking for. So if I want to check that an end user can do something with an application on the graphical user interface, then I need if I want to write some automation that checks that, I need a tool that operates on the graphical user interface. However, that's just a small subset of the whole suite of tests that you want to perform. So a lot of times you'll be focusing on testing business logic, testing algorithms, testing the implementation of decision tables, business rules, stuff like that. And unless your application is incredibly badly built, you will not need the graphical user interface does not play a role in the implementation of that logic, of those algorithms, of those business rules. They are often exposed via APIs. So if you want to check that business logic, it often makes much more sense to test that at the API level. Also, app systems, applications are becoming much more distributed nowadays. So instead of having this one big monolith that does pretty much everything, we have applications that are built out of a lot of different components, microservices often, that all perform one specific task and communicate with one another via APIs. So there's a lot more potential, many more opportunities to write tests at the API level. And these API level tests, they just run much quicker. They're easier to write than tests, for example, using Selenium or Cypress or Playwright. They run a lot. They run a lot faster, so they give you that feedback that you're looking for in your testing a lot quicker compared to these relatively slow and hard to maintain tests that run against the graphical user interface.
Okay.
All right. So let's get started. So the first challenge that I have is to have my write some code that performs the actual GET request that we've been doing here. So it actually retrieve this data and check that the response status code, so the HTTP status code, that is the first indication of was this request processed successfully, is equal to 200. So what we want to do is perform an HTTP GET to a specific endpoint, capture the response, and check that the response status code is equal to 200. Now, so we're going to replace this assert false with an actual test that makes sense. And the way to do that is to simply so my first line of code here is a call to the requests library, which is not there, but it is part of my project. So all I need to do is import it to make the library available in the module that I'm working in. And this requests library has a number of utility methods for each of the HTTP verbs. So get, post, put, patch, delete, etc. One of the ways to call it, the most straightforward way to call this get method is by passing it the endpoint that you want to get, where the data resides that you want to retrieve. And this method, this get method, it returns the entire response, so the HTTP response, as an object, as a Python object, and I'm going to temporarily store that in a variable called response. So this single line of code is everything you need in Python to create an HTTP request, to actually send that HTTP request that HTTP GET to the endpoint that you specified, and to capture the response and store it in a variable. That's it. This is all you need to do. And that's exactly what I meant when I said, well, request is simple but powerful. This single line of code creates the HTTP request again, sends it, captures the response, and stores it in this response variable. And the only thing we need to add now to make this a meaningful test is the second line here says check that the response status code is equal to 200. Mm-hmm. Now this with PyTest you create an assertion using the assert keyword, and the only thing we need to check is this response object has a number of properties, so the content, the text, the headers, but also the one that we're looking for here, which is the status code. And all I need to do is check that this is equal to 200 to make this a meaning. Again, this is the hello world of API testing, performing a call and checking the response status code. But these two lines, line 7 and 8 that you see on the screen here, are everything we need to make this work. So if we now run the test again, we can see that even though there's 7 tests that are still failing, there's one test that passed now, and that's our first test. So at PyTest, the way PyTest outputs this here is with a little green dot, and that is our first test. So just to and that's, by the way, that's just a very good practice to do, I think, with all of your tests, is once you've written a test and it passes the first time, start doubting yourself. I do, because now I want to know, is it really this straightforward and this easy? And just try and make the test fail, just so you know it checks the right thing. So, and I've changed the expected status code from 200 to 201, and now I've got 8 failed tests again, which means that the 200 is actually being checked, being verified properly, and this test is ready to go. This test is done. So that's the first one. So what we've done now here is, again, using PyTest and the request library, perform an HTTP GET to a specific endpoint, capture the response, and check that the status code of the response is equal to 200. Let's see what else we can do here. So the second thing that I want to show you is, again, submit the same GET request. I've separated, I'm putting this in a separate test on purpose, so you can follow along with each step. So I'm making a new HTTP call in every single test. If you say, well, I want to add a second assertion to the same test, that's fine, but I'm not going to do that in this demonstration. So I'm going to write to perform the same HTTP call again, but in a different test. So the first thing we need to do again is perform that same API call. The second property that I want to check in the response is to see if that content type header that we saw earlier here, so this one, has a value that's equal to the value that we expect. So in this case, I want to check that the content type header is equal to application JSON. Now, in the previous exercise, the previous example, we've inspected the status code. what I'm going to expect now is the headers. That's probably not a surprise here, because the headers and in this case, the way the request library stores this is just a regular Python dictionary. And for those of you who don't know what a dictionary is, it's a collection of key value pairs where the keys are the names of the headers and the values are their respective header values. So, and the way to oops, by the way, I'm incredibly inconsistent with single and double quotes in Python. Luckily, Python is very forgiving. So what I've done here, I'm performing that same API call, but instead of the status code, I'm now checking that the content type header is equal to application JSON with a character set of UTF-8. So these straight bracket, and this is the way in Python to retrieve the value corresponding to a specific key from a Python dictionary. And I run this test. We now got 2 passing tests. Just to show you what's happening, let's change this 8 to 9. It fails again because, well, it's UTF-8, not UTF-9. Another exception that you might have is that you might receive is, well, I'm referring to the actual header by its name. So what if I enter a name that's not there? What if I try to retrieve a header that doesn't exist? So let's change the name of that one. This will actually also throw or raise, in Python terms, this make my test fail. This is a key error. And if you see a key error in your Python test, it means that you're trying to retrieve a value in a dictionary by a key that doesn't exist. So the requests library converts the collection of response headers to a Python dictionary for you. But if you want to retrieve the, if you try to retrieve a header, a key, a header name that does not exist, your test will raise a key error. So let's do this, change this back to content type again, and we have a passing test. Awesome. So we've checked status code, we've checked response headers. Let's have a look at the actual data. So the third challenge that I've come up with is checking that the response contains a field called name. I'm not interested in the value yet. I just want to know that this name field exists. So again, I'm just copying the response. Yes.
I think there is a need of increasing the font. Could you do that?
Absolutely. Yeah. There we go. Better?
Much better, of course.
Excellent. Excellent. No problem.
Yeah.
So to be able to access the data that's to be able to access the data in a convenient way using the request library, there's one extra step that we need to take compared to these previous two challenges. By default, the response object will contain the response data in just a raw byte stream. And that's because REST supports a lot of different data types, really. So a REST API can return data in JSON, but also in XML, or it returns Word documents or MP3 files or video files, stuff like that. So REST isn't tied to a specific data format. But also the JSON data format is very similar to Python dictionaries again. So a JSON is basically a JSON document is basically a list of key value pairs, where the keys are the element names and the values are the element values. And request has a convenience method called JSON. So what this method does, so what you see here on line 22, is it extracts the data in the response body, and it tries to convert it into, again, a Python dictionary. So that's what this JSON method does. So obviously this will only work if the response data is actually JSON. If it's XML or if it's JSON that cannot be parsed, this will, oops, I didn't want to do that. This will again raise an error. But in this case, because our example API returns JSON, we can use this JSON method to transform the JSON string into a Python dictionary. And we can do assertions on that in much the same way. So if I want to check that this response body, which is now again a Python dictionary with all the JSON elements that are in the response body, contains a name element. This is all you need to do. Check that the key name is a member of this response body Python dictionary. Again, just check, or actually check it. Yeah, now we've only got 2 passing ones. So aim is not in there, but name definitely is. So we now know that this response body field exists. Most of the time, you don't want to just check that the field exists. You also want to check on its value, and that's the same as we saw with the headers. It's just we need this extra step to convert our body to a Python dictionary. But once we've done that, we can just access the value with this square bracket notation. Put the name of the field that we're interested in there, and that'll return the corresponding value. So now we've got 4 passing tests. We're moving along nicely here. So if you just want to check that a field exists, you can do it like this. And if you're actually interested, so this implicitly checks that the field exists, because if the field doesn't exist, there's no way to access its value. Oops. And again, this raises a key error if for some reason this field cannot be found. But in this case, it passes, so that's good. So this was a top-level field, this name field. There's also a name field as part of this company field. So the value of this company field is again a JSON string with 3 fields: the name, the catchphrase, and the BS field. So say we're not interested in this name, but in this name, for example. So this is something that I cannot pronounce, Romaguera, something like that. If you want to check on that, we can do that by first accessing the value of the company field, because a Python dictionary is again a collection of key value pairs, and the values they can be just strings or integers or booleans, for example, but they in itself they can be dictionaries again. So this JSON method, this converts the entire JSON field, even if it has nested elements and with lists in there, or where the value of an element is again a JSON string in and of itself. It'll just convert it into a dictionary inside of a dictionary. So what this returns is basically a new dictionary with 3 elements in there: name, catchphrase, and BS. So, and if so, yeah, so because it resolves from left to right, this will extract the value of the company field, which is a dictionary again, and then I can access the name field that's in there and say Rona. Yay, 5. Just to check that we're actually checking the right thing. It does not like this. Cool. So if you have nested response body fields, you can just drill down into the structure using this square bracket notation. If there's an array in there, you say, well, I'm interested in the first element in that array, and you can one way to do that is to access it by its index, which you could again do using these square brackets, but with an integer, passing it an integer to point to an element at a specific index in that list. But in this case, that's not necessary. A slightly different request. So this HTTP GET returns the data for the user with ID 1. This one returns a list with the data for all of the users. So in this API, there are 10 of them, starting with ID 1 and ending with ID 10. So for example, if I want to check that there are actually 10, there are 10 users, I need to make sure that to call the right endpoint. This again is an HTTP GET. I can do that again by converting this response to a Python dictionary, and then just asserting that len is a Python built-in function that returns the length or the number of objects in any type of collection. So let's check that. So we've now got 6 passed tests, which indicates that, well, the length of this response body is actually 10. I don't need to point to a specific element in this response body here because the list is at the root level. It's also perfectly possible for JSON elements, and the values of the value of a JSON element can also be a list. in this case, that's not true. The list is just the root element of this response body, and that's why we don't need to point to a specific element. But if there was a root level element called data, for example, and the value of that one was of that data element of the data field was a list, was a list in JSON, you can simply point to that element like we've done in the previous examples. So, and just to make sure we're actually doing the stuff that we want to do here, I just in case you hadn't noticed, I really like confirming that my tests actually do what I think that they do.
Yeah.
So we've seen verifying status codes, verifying response headers, verifying response body data. Let's see that how to send data, because these were all HTTP GET requests, so requests to retrieve data from an API provider. Often you'll also want to test if the API provider is able to process data that you send to it in the correct, in the expected way. So our API, if you go to the, let's close this one. So there's a list of routes. So all HTTP methods are supported. The one I'm interested in here is this one. The post to posts. So this one creates a new post. So a post is it's associated with a user. It has an ID in and of itself, and it has a title and a body. So it's a relatively simple JSON structure, it's a relatively simple data structure, which saves me a lot of typing. And that's good. I like saving myself a lot of typing. So the first thing we need to do now is create a new post. And that is as simple as assigning a user ID to it. So this is the way in Python to create a previous exercises is transfer agent string JSON document into a dictionary. What I'm going to do now, because now I'm not retrieving data and checking it, but I'm going to send data. I want to do the serialization, so the other way around. So I'm creating a Python API, and then I'll need a way to tell the requests library to take that Python dictionary and convert it into an actual JSON payload. My post title, and this one is my post body. So in this API, I don't. So even if I retrieve a post, it'll contain an ID. You don't actually need to send that to the API, so that's why the ID field's not in here, because that's auto-generated by the API provider itself. In the previous examples, we used the get method because that resembles and corresponds to an HTTP GET. But of course, you are going to use the posts method. Again, let's pass it the endpoint. But now we also need a way to attach our Python dictionary, so the data that we want to send, to this request. And in Python, that's as easy as using a named parameter called JSON. As the value of this named parameter, you can pass in any Python dictionary. What requests will do for you is basically the reverse process of what we've seen earlier. It takes a Python dictionary and it transforms that automatically into a JSON string before sending it to the endpoint, before sending it to the provider. So you don't need to do that yourself. That's all being taken care of by the request library for you. Again, if this dictionary is incorrectly formatted, it'll raise an error. If this is a valid Python dictionary, it'll come. So using the JSON, the JSON name parameter, that'll automatically convert this dictionary to JSON for you. There's also the data named parameter, which you can also use, but this does not do the transformation from Python dictionary to a JSON string. So you can, if your API accepts XML, for example, or plain text, or something else. So, for example, if I want to send this as data, I could just pass it here as this one, and this will not do any conversion. So this will just pass the raw string that you've created here to the API endpoint. But in this case, I like to just create a Python dictionary because that's easy and straightforward. You can do that programmatically. This one is hard-coded, but maybe it's you have a different way of constructing this dictionary, and all you need to do is pass it as a value to the JSON using name parameters to the JSON parameter, and request will try and convert this into actual JSON. Oops. Status code. And the typical status code for a successful HTTP post is A201. So let's see what this one does. It also passes. So this means that even with just a few lines of code here, I've created my Python dictionary that represents the JSON data that I want to send me by converting this into actual JSON. I've posted that to and I've checked that the response status code is equal to 201. Okay. How are we doing for time, AJ?
Could you repeat, Bas?
How are we doing time-wise? How much time do I have left?
No, you can continue when you want. Of course, I know you can continue for hours, but
yes.
But
no, I'm just checking because we're close to an hour already. I've got one more, so it's not that much. I just wanted to check if there was still time to do this final example, because I think it's pretty interesting and powerful as well. Just wanted to check.
Go ahead. We have ample of time. No worries.
All right. So the final thing that I want to show you, again, as you rightfully said, AJ, we could go on for days here, but we're not going to do that. one thing that I definitely wanted to show, though, and that's because it's something that we see used so often in, especially testing at the API level, because again, APIs often expose business logic, algorithms, business rules, that kind of stuff. What you often want to do is, because if I want to check the implementation of a business rule or a piece of business logic, I typically need more than one test case or example to do that. So I need more than one set of values to pass to it. So if I want to check an algorithm that calculates a train fare based on the distance someone's traveling and their age, because maybe there's a reduction for people under 18 and people over 65, for example. I need more to completely test that. I need more than one test case. So I need a test case where I've got a person who's under 18. I've got a test case where there are people between 18 and 65, and I have test cases for people over 65, for example. Mm-hmm. So the straightforward and ugly way to do this is to just write multiple tests that do the same, and that basically repeat the same logic, call the same API endpoint or endpoints, just with different sets of data. That's the ugly way to do it, because you then potentially end up with 3, 4, 5, 20, 50 different tests that all exercise the same application logic, just with different sets of data. And in this example, the tests are short. It's just 2 or 3 lines of code. But in practice, that can often, because the applications are bigger there, that can be 10, 20, 30 lines of code. Times 50 is 1,500 lines of code, and with a lot of duplication. Mm-hmm. There's a more elegant way to do that. And I must say that's not a feature specifically of requests, but more of a feature of the underlying unit testing framework. So in this case, of PyTest. If you were to do this in Java, it's a feature of JUnit, the test-ng. If you want to do this in C#, these are features of NUnit or MS-test or XUnit. The reason I'm showing it here is because it's often so useful at the API level, because that's where this business logic, these algorithms are exposed. So that's a perfect level to test the implementation of that business logic, much more so than doing this at the graphical user interface level. So what I wanted to do, just to give you a quick example of how this works, is in a previous test, we retrieved the data for the user with user ID 1, and we checked that the name is equal to Leanne Graham. So let's say that that's our business logic, putting in a user ID and retrieving and checking on the name. But I want to do that not just for the user with ID 1, but also for the user with ID 2, and for the user with ID 3. So basically, what I want to create something that's called a parameterized or a data-driven test. I've done a little bit of preparation beforehand, and that preparation is creating my test data set. Mm-hmm. So, and let me just add a couple of line breaks here to make it a little bit easier to read for you. So this test data is a list, and each list, the list contains 3 tuples, Python tuples in this case, and each tuple represents a test case, and a tuple can have 2, 3, many values in Python. So, but in this case, we only need 2 because there, from one iteration to the next, from one test case to the next, there are only 2 things that change. The user ID that I use in the request and the expected name that I verify as part of the response.
Mm-hmm.
So, I need a way to pass this to my test. So I've created again an empty test method here. I need a way to pass this to the test in a way that the unit testing framework understands. Well, this is not really just one test, but actually 3 tests. So it's going to iterate over this list of tuples. Now, each unit testing framework, most, if not all, unit testing frameworks that I've worked with support this because it's so common. But each unit testing framework does it in its own way. So the principle is there in all unit testing frameworks. It's just the syntax and the way you do it that's a little bit different. In PyTest, and now I also need to import PyTest here to access its functions. Parameterize user ID, expected name, and this is my test data. So what I'm telling PyTest here is, please create a parameterized test, and in PyTest you do that using the parameterized marker. Mm-hmm. Use this object that I've created, so this list of tuples, as your data source. And this assigns names to the columns or to the fields in the tuples. So this user ID corresponds to the first element in the tuple, and this expected name corresponds to the second one in the tuple. This PyTest does this so you can, if you want to, you can switch up the order in which the values appear in these tuples. I'd recommend you to just keep them the same, just for readability. So if the user ID is the first one, then just list it as the first one. So now, because I've added this parameter, I also need to pass those values as arguments to my test method, because I need to be able to access them in the body of my test. And that's why I'm adding these parameters here. And these names need to correspond to these actual parameter names. So if I change this up, it says, well, I have no ID what this is. Let's see, which one can I steal? This one. Perfect. I like stupid. So I've copied a previous test where we actually checked the name, but here and now, instead of using this fixed user ID and this fixed expected name, I want to use the values that are specified here. So this is easy. This is just replace this by the expected name. So this will be Lee and Graham for the first iteration, Irvin Howell for the second one, and Clementine Bau for the third one. I can do something similar with using this is by the way why I love Python. It's so easy to create formatted strings with placeholders. It's just putting an F in front of your string for format, and then you can just put placeholders in there between curly brackets and add variables, objects, or even entire Python expressions in. Oh. So let's Okay, and we've now got a working complete test run with 10 passing tests. So the number of tests has always, so far, was always 8. Now there are 10. Why are there 10 now? Because this one, even though it's just one method, this is actually being run 3 times. Once for this test data set, once for this one, and once for the third one. And these are actually, I could do this with a for loop, for example, inside this method. Please never do that, but I could. Why do I say please never do that? Because if I do this with a for loop inside this method, all of the iterations will be interpreted by a unit testing framework, by PyTest in this case, as one single test. So if this one fails, because the user is not called Leanne Graham, but Big Bird or something, these ones will not be executed. By doing it properly using the parameterized marker, PyTest will treat these as 3 separate tests instead of one test that just loops 3 times. So, for example, if I change this one to Big Bird, you'll see that, well, yeah, this user isn't called Big Bird, but Erwin Howell. You'll see that the other tests are still executed. So this one is still executed and it passes. This one is also executed and it passes. It's just this iteration that fails. So PyTest sees this as 3 different tests, even if we only have a single method in our test code. Oops, there we go. And if I want to add another test, it's just a matter of adding a 4th, and I have no idea what their name is, right? If I want to add a 4th iteration, it's just a matter of adding 1 tuple to the list. And I now got 11 tests. So again, this is not a feature of requests per se, more of a feature of a unit testing framework. The reason I want to show it here and demonstrate it here is because this is something you often use at the API level, again, because that's where business logic, algorithms, business rules are often exposed, and where other layers of your application or other systems, other components can consume the result of that business logic or algorithm. All right, that's what I had to show you with regards to Python and the requests library and PyTest, and how you can use those tools to write API tests. I know you've got a couple of questions left, AJ. Before, and we've got some time left, so I'm more than happy to. I'm not sure if we're going to answer all of them, because that might be, but fire away. But before we do that, again, I just wanted to show you that all of the code that you've seen, so the exercises and the answers, they are available on GitHub. So please, if you want to have a look at them, play around with them a little, have a look here. And if you want to know more about requests, because again, we've only got just over an hour, and that's not nearly enough to show you everything that you can do with API testing in Python using requests. I've created a workshop, a free and open source workshop, that's available here on GitHub, and that contains first, well, the README basically explains it all. So there's a slide deck, which you can refer to go through all of the things that I've told you here, and there are 6 series of exercises here for you to practice for yourself. So the slides show you some examples of how to do things in Python with APIs using requests. I've got exercises for you to practice for yourself, and if you get stuck, the answers to those exercises are here. So that this workshop covers what we've seen in this session, but also much more. So there are also exercises to work with XML, sending XML payloads, verifying XML responses. There's a bit about API mocking in there, using the responses library, and a couple more things that I can't remember right now. And one of the things that I want to add that's not yet in there, and that we've also not covered here because that's a whole separate topic, is working with GraphQL APIs. So what we've done here is we've interacted with standard REST APIs. But you can use requests just as well to work with GraphQL APIs. So that's something that's still on my list to add to this workshop. But that's another thing that you can do with Python and with the requests library. So yeah, by all means, it's all free. It's out there if you want to have a look. Yeah, this is where you can find it, and I'd love to hear what you think about that.
All right, boss. Definitely, we will look into github.com where you have kept all the resources for us. So now we are heading towards Q&A session. Shall we proceed?
Sure. Yes, absolutely. Do you want me to stop sharing my screen, or?
It's up to you, whatever you want.
Okay, I'll just leave it on, and if I want to look something up, then I can just do it on the fly.
Okay. So coming to the questions part. So what do you think should be a prerequisite skills for a beginner to start looking into API testing?
So first of all, be a good tester. So I've got and this is by no means meant as shameless self-promotion, but I've got an API tester course, and what I start with is how to do exploratory testing on APIs. So, and we all know exploratory testing or using graphical user interfaces on applications to see what an end user might actually do. But you can do that on APIs as well. So that's where I would start. And why do I say that? Is because automation and things that we do and the things that I've demonstrated here is just a way to make your testing more efficient. But before we can make our testing more efficient, we need to know what to test for and what to actually look for in APIs. So, and before you dive deep into programming languages and tools and frameworks, know what API. The first thing I teach when I teach API testing and that I recommend people learning is get comfortable with the concept of APIs and what requests look like, what responses look like, how APIs are used in applications, what you can do with APIs before you start diving into tools, because only if you understand what's happening there with APIs and you know where the risks are, and you know what to test for, only then does automation make sense, really.
Okay. Coming to next question, boss. So is there any language preference for performing API testing?
Sorry, what kind of reference?
A programming language preference for API testing?
No, not really. So no, that's the way too short question. So the requests library that I've shown you, if you would look at the source code of the request library, it is a wrapper, an abstraction layer on top of standard HTTP libraries. Pretty much every programming language that I've worked with has a similar library or multiple similar libraries. So I don't really, I like requests. I love Python because it's really expressive. You don't need to write a whole lot of code. I'm looking at you, Java, where you need to write a lot more code to get things going. But in Java too, you can do the exact same things that we've done. You just need a different unit testing framework and a different API testing library. So do I have a preference? Yes. Typically what people ask me is, what's your favorite language or tool? And that's the one that best fit my client needs, really. So if you would really, so I was brought up, so I got my education mostly in Java. So that's the language I probably know best. But that doesn't mean that that's the language and the tool that I always going to be using. So if my client works with Python, I'll use PyTest and requests. If my client uses C#, I'll use something like NUnit and REST#, maybe. If they use Java, I likely use JUnit or TestNG and probably REST assured. Tools are just tools, really. So if you understand how it works with requests and PyTest, and you don't just know about, you don't just learn what a tool does, but also what it actually is that you're doing, I find it pretty easy to switch from one tool or one language to another one. So actually understanding the fundamental principles and patterns and practices, if you understand those, then picking up a new language and tool and this goes for automation or for software development in general, but it definitely applies to API testing as well. If you understand those fundamental principles and patterns, picking up a new library or even programming language is not that hard.
Okay, got it. Coming to next question, boss. So what are the ways of performing API testing? We know there is manual or automation testing, which we can apply on performing API testing. What should one prefer out of these two?
A good mix of both. So API testing is typically a little more tool heavy than testing through or via the graphical user interface, because you'll always need a tool to communicate with an API. That can be something as simple as a proxy or just your browser with some maybe with some additional plugins or extensions. It can be a tool like Postman or SoapUI, and it can be a code library. But still, that there's still, again, what I said earlier, you can definitely perform exploratory, and you should perform exploratory testing on APIs as well. So and this is why I am glad I still shared my screen. There's a great course on this on Test Automation University by Amber Race, she created a course called Exploring Service APIs Through Test Automation. But this course is not just about test automation. It's also about exploratory testing on APIs. So this is where I got a lot of my ideas around testing APIs in general, not just writing automation for APIs, but testing APIs in general. I got a lot of the ideas from this course. So yeah, that if you want to have a if you're looking to create a solid API testing strategy and not just the automation, this is a course, and again, this is totally free for everybody to, as probably most of you know, Test Automation University.
Yeah.
This is a great course to get started on with API testing in general.
Okay, got it. Coming to next question, boss. If we perform API testing in detail, then do we really require UI testing, or one can ignore it? Then how should be the testing efforts driven among API and UI?
Okay, so I'm going to try and answer this question without referring to a certain pyramid that we all know of. It's all about finding the right mix, I think, between so as I said earlier, business logic, algorithms, business rules, they are often exposed through APIs. So if that's what you want to check, the implementation of those business rules, you don't need to doing that through the UI probably isn't the most efficient way to do that, because that's not implemented. The UI layer is not part of the implementation of that business logic. Basically, the UI layer is a human-friendly way of interacting with those APIs. And now I'm selling all these front-end development and UX designers way short, but that's a guaranteed way to get into a fight with front-end developers, by the way. So it's just a dumb way to interact with API. So please never do that. But it's all a matter of what information am I looking for, and what layers of my application, what components of my system are involved in exposing that information. And often that is that does not necessarily include the graphical user interface. Again, graphical user interface automation is the hardest form of automation to write, I think, in my experience. And everybody starts there. I don't know why. I know why, but I still can't get my head around that. But no, you'll probably, so if there's a graphical user interface involved in your application, you'll always need a bit of testing around that as well, because this graphical user interface layer, it translates the data that's being returned by the API, the logic that's being returned by the API, into something that the human can see and interact with. That's not what the API. So if the thing that you're testing, the information that you're looking for involves that translation, so that part of what your application does, then you'll need a GUI test, so graphical user interface test. If it's purely the business logic that you're testing, the backend business logic, that probably does not involve the graphical user interface. So it's probably a better idea to test that, try and test that at the API level, for example. And I'm going to see if I can quickly pull up a blog post. Don't repeat. Let's hope that helps. Yeah, this one. So this is a relatively short, but it's been there for a couple of years. But this is basically what I repeat over and over again So thanks, Chris. Once again, don't repeat your past. So if you find yourself going through the same flow of screens in your application, just with different data, there's probably a more efficient way to test that, and that's often at the API level. So this blog post explains that, but in a much more eloquent way than I could ever explain it.
Got it. Okay. Definitely we will go through this blog as well to understand it better. Okay, coming to next question, boss. So,
sure,
as you know, like automation tester always start from an UI. So, how could an UI automation tester switch to API testing?
By thinking and by let's start with talking to other testers and to developers in your team, and show them what you're doing, and just asking, and that's a question I teach often, is again, testing is all about gathering information. So a question I've learned to ask a lot more often is this the most efficient way to get the information that I'm looking for? So, and that for this specific case, that translates to, I've been putting probably a lot of time and effort in writing these graphical user interface tests, but are they is this the most efficient way to get the information, the test results that I'm looking for? That often opens up a discussion, especially when you talk to developers and they say, well, we've also got this API layer that you could potentially use for your tests, even if only to create an initial state, for example, for your tests. So and that's where APIs come in very handy as well. So create a new user or an account or an order or a customer or whatever, because you need that in your UI test. So yeah, talk to people really, and then try and learn from others. If you say, well, and because API, yeah, I don't really know how it works because there's no graphical user interface there. But as you've seen, hopefully, in the examples that I gave, once you find the right tool set and once you know what's going on, writing API testing code is actually much easier than writing UI testing code. And it runs a lot faster too. So yeah, talk to people, find examples, see if you can make your existing test suite a little bit more efficient by adding some API calls. Maybe that replaces some of your UI tests, but it could also be used to make your current UI test more efficient, because you create an initial state, for example, through APIs rather than having to do that through the graphical user interface as well.
All right, got it. Okay, coming to next question. So, what kind of reports one can get after performing API testing?
What kind of reports?
Yeah.
It depends what you put into it. Really. Right. So typically these API testing libraries, such as requests that we've used, they don't do reporting. So there's no reporting functionality in requests. There's no reporting functionality in REST Assured. There's no reporting functionality in REST Sharp. Because that's not the responsibility of that library. That's typically done either by the unit testing framework, because that gives you some basic logging, just in a form of, I've run 20 tests, it took me 15 seconds, and tests 3, 5, and 12, they failed with this error. And basically that's all being done using the test method names and the results of the assertion statements that you put in there. That's not really all that different with API testing. So it's just that the assertions are on a different level. So instead of checking that an element is present on a screen, you check that an element is present in a JSON body. And if it's not there, then it's and there's this mismatch between an expectation and the actual outcome. And that's what the reporting is all about. So I've seen a lot of reporting frameworks that include these pie charts and screenshots and stuff like that. You can do all that with API testing as well, apart from the screenshots, because there's no screen. But other than that, it's just a nice summary of which tests have been run, and that's basically identified just by the test method name or maybe a custom description, and what were the results of the assertions that I've put in there. And it's just a different type of, or it's the same type of assertion, but it's different values that you check really. But other than that, it's not really all that different from other types of reporting. I don't know how you're doing for time, by the way, but I don't know. I've got time for one more question, maybe. Then I need to go, unfortunately.
Okay.
If that's okay with you.
No worries, no worries. So, one and final question to you, what kind of skills should today's tester have?
That's a very good question. I love that for a final question. It's unfortunately also a bit of a long answer. Again, it depends on your role, what you want. But first of all, still critical thinking skills and question asking skills. That's always been the case. But that's still the case. That's what makes a tester a good tester, in my opinion. The ability to ask the difficult questions, but what happens if I do this kind of questions, instead of let's see if this works kind of questions, which are part of what we do as testers, but it's not what makes a tester a good tester. And that's the critical thinking, the asking the difficult questions, the knowing from experience or from using other kinds of oracles what might happen if I do X, Y, and Z. So that's still something, and unfortunately, a lot of testers seem to forget that these days. They focus a lot on technology and on tools and on automation, which is all fine and good because automation is great. But I feel that a lot of testers they lose that thing that sets them apart from developers, for example, and that's those critical thinkers. So that's definitely still incredibly important as a tester. Those actual testing and exploration and critical thinking skills. Having said that, you just a lot of companies are asking for testers to become more technical as well, to contribute to the automation, to work more closely together with developers, which means that you don't need to be able to write all of the production code, but to some extent you need to be able to talk to them about it, and that means that you at least to some extent know what it is that they're doing, what challenges they are trying, what problems they are trying to solve, and which tools they use to do that, and contribute, have at least have an opinion on, but also contribute to automation, which means you'll also, and again, and this has been said, I see this on my LinkedIn feed at least 10 times a day, which is a good thing, but test automation is software development. So it means you need software development skills too. And that doesn't mean you have to be an excellent programmer, but you have to have sufficient technical skills to write some code, to read some code, to interact, to be able to discuss code with people. So yeah, that's next to these actual testing skills and these critical thinking skills, that is something that as a tester, it's really hard. You're making it harder for yourself if you don't have at least decent skills in that area as well.
All right. Thank you, boss. So thanks, boss. Finally, we have reached the closure of this wonderful session on API testing using Python presented by you. I want to know if anyone wants to reach out to you with their questions, then what are the ways for reaching out to you?
The best way is probably by email, bas@ontestautomation.com, or just hit me up on LinkedIn. That's I'm pretty active on LinkedIn, as you might have noticed. Sorry for all the spam, but that's a great way to get in touch with me as well. So yeah, and I'd love to hear what people think of this session, if they have anything to add, any reactions. If you thought it was great, if you thought it sucked, let me know. I'd love to hear from you.
Awesome. Okay. Anything else you want to share before we wrap up this session?
No. Other than thank you for having me and for being a wonderful host. I really enjoyed doing this. It gave me an opportunity to experience with a different type of session, so without any slides, and just do some live. I really enjoyed that, by the way. I hope that came across to the audience as well. So yeah, thank you for having me. Thank you for the opportunity and for being a great host and preparing all of these great questions. I really appreciate that.
Thank you, boss. Thanks, boss, for joining us over STET and sharing your knowledge based on your experience in your tenure in the IT industry so far. I hope our audience will learn a lot from this session, and we would be expecting more such deep dive sessions from you in upcoming days as well. We wish you all the best for upcoming projects on which you're working on, and thanks for being part of our STET journey.
Again, thank you so much for having me, AJ. It was a pleasure.
Thank you. Thank you, boss.